All right, here's part two of that recording for the lecture. Sorry it took so long, but just going strong on a fun, busy night. The next couple problems where you're doing derivatives are a part of this story, so you have to remember we're still doing derivatives, which is a way of finding the slope of the tangent line at a given point, but then we have to answer some larger questions, so there's a lot of other work that goes with it. So kind of hang in there on the steps and find good ways to ask questions along via email or otherwise too, because these can be a little bit tricky. So this first one, I'm going to take a particular tack until we're going to do option one with transformations, and there's another one that what we're doing is we're going to bypass. We're doing this without what's called the chain rule. We'll learn pretty shortly. So it's a method of doing derivatives of this type of problem. So we're not using another option that will come down the pike, but I'll just mention it just so you have that word in your brain. There's something called the chain rule. So I'm going to take this and I'm going to treat this function like I'm going to transform it. I'm going to realize it's a radical graph that's been moved left 2 and use that to our advantage. So here's how it goes. So here's square root of x and the square root of x plus 2. And you can see they're just slid. One slid to 2 units to the left from the other. So square root of x is one of our parent functions we went through. If the question's asking us about the point, what's going on at 2, 2 on the red transformed graph over there, then I can actually answer, if I want to know the slope of the tangent line at that spot, how steep it is, I can actually look at our regular square root of x graph at the point 2 units to the right of it, at 4, 2. And because I have a way of getting the slope on the square root of x at 4, 2, because I can take the derivative of the square root of x. I can't, at this moment with our skill set, do the square root of x plus 2. So I'm going to use a little trick here where I'm going to get the slope, but I'm going to use square root of x to do it, and then just transfer that information over to that other green point at 2, 2 and utilize it. Okay, so here goes. So the slope is the same here in each situation with those green points. Square root of x is just easier to work with, and I keep pressing my little play button as we go along. I made these notes. So you kind of sometimes just work with what you know and then transfer the information, but I know it's the slope of the tangent line that I need as part of this question to get the equation of a tangent line. The slope is part of that. Okay, so next piece. The slope, if I take the derivative, I'm going to have to, of square root of x, I need to rewrite it with some algebra. And if you write it as x to the 1/2, then you can use our power rule, where you bring the power out front and reduce it by 1. So therefore, f prime of x is 1/2 x to the negative 1/2. In itself, that has its own algebra. The negative exponent I can flip to the denominator, and then a half power is also known as a square root. So a lot of little things that I know it's going fast. Obviously, pause and rewind or check in with me. But that's the idea, is I can get the derivative of the square root of x, and it's an important one to know how to do. I couldn't, at this moment, get the derivative of square root of x plus 2, but I'll use that information. So I'm going to get the slope at 4, 2, and what I'd use is just the x. Just put in x equals 4 into this equation, and I get the slope of the tangent at that spot. So check it out. Let's go for it. Slope, plug it in there. Okay, it's going to be 1/4, because I plug in x to the derivative. That's how the slope of the tangent looks, that spot. That means that's the slope is 1/4 also at that other point, because remember, they have the same slant. It's the graph slid to the left 2 units. So by getting it at one point that I know, I can slide the graph over 2 units and get it at a mirror point on that red graph that I'm interested in. And that's the whole point. I needed the slope on the graph of square root of x plus 2 at the point 2, 2, and I've got it. It's 1/4. With that, I can take that slope of 1/4. Okay, this is going to recopy all that information just so you kind of see it in a clean slate, because there's a lot of stuff on that last page. But now what I can do is just say, all right, this is what I know. At that location, 2, 2, slope of the tangent's 1/4. I need the equation of that orange line that I just drew, which means not just the slope, but I also need the y-intercept. So let's plug it all in. Got the slope, 1/4. Now I can plug in the point 2, 2 for x and y, and we can find that slope, that b. And sorry that went a little bit faster there, but basically, remember, you can take the slope that you know and the point 2, 2 that we know, plug them all in and solve for that b. And that gives you a chance to solve for b, plug it back in, and we have a brand new equation with 1.5 as our b and 1/4 as our slope. And there's the equation that it's asking for at the very beginning. But you kind of realize there's a lot of work to get us there, so you kind of have to keep focused on the end goal of, I just need the slope at that point 2, 2. I found it from using the square root of x graph 2 units to the right. And then once I got that, then I used the slope of 1/4 and a point x and a y point 2, 2 that I knew, and I solved for the y-intercept. So next piece, this is kind of a goofy, things to just keep track of, how to answer the question. It says, and I'll use alternative form of the derivative to find this, and really in this kind of a situation with absolute values, we draw graphs. So if you can draw a graph of a function, knowing a little bit about our base functions, sometimes that's enough to answer the question. So we learn those basic functions so that we can do things like, hey, isn't that v graph to the left 9? And sure enough, it is. And then the answering the question, what's h prime of negative 9, means what's the slope of the tangent at negative 9? And we all see that there's that cusp right there, or that corner, as some call it, because there's slopes that don't go to infinity there, but we can call it a corner, cusp. I'll go with either one. It's undefined. You can't get a slope at one of those corners or cusps, whatever it is. So that's what you put in there. And it's a pretty easy question from there. Finally, if you take on and find the equations of the two tangent lines, what we need is the points at those two places of tangency, and we need the slopes at those two places of tangency. So here goes. First thing I want to do is I'm going to go get the points at those spots. I think it's at x equals 3 and x equals 5 that those points exist. And I think they're both at a height of 15, but to be sure, I actually plugged them into the equation just to be extra sure. And sure enough, yeah, they're both 15. So eyeballed and with algebra as well. Next is I take, now that I have those points, I need the slope there, which means I need the derivative. I need f prime to get the slope of the tangent line. So f prime of 3 and f prime of 5 would be what I needed to get the slope of the tangent. So here's f prime, 8 minus 2x, and that's just using the power rule. And sorry, it skipped a little bit in there, but f prime, just using your general power rule, 8 minus 2x, pretty straightforward. I hope that's all right. 5, if I plug that in, I get out negative 2, so the slope of the tangent at 5 is negative 2. Makes sense, it's downhill. And the next one, the orange one, if I put in f3 into the derivative, I get 2, positive 2, which also makes sense. They look like the same slope, just opposite directions. And now that I have the slopes, I have part of those equations, 2 and negative 2 respectively for their equations. I just need their respective y-intercepts, which are quite different. So I need to put in their unique points to make that happen. 315 for the one on the left and 515 for the one on the right. And if I sub those in for x and y, I can solve for b, or that y-intercept. Okay, so here goes that piece of it. So for the first one, 15 and 3 go in for y and x. Find out b is 9. Here's my equation. And then I'm going to use the other point, 515, plug those in for y and x, and find out a y-intercept of 25. Those look reasonable, just looking at the graph. I can see one of them crossing at those two locations, and we're good. Those are our two equations. That's it. We made it to the end of that's a big introduction of just using the derivative in a couple contexts, and then the power rule and a few little algebra tricks. So next I'll get you guys ready to get into homework, the second homework in Chapter 3, and there's some other derivative big questions and big ideas that can be confusing. So keep those good questions coming. Take care.